Welcome everybody to the second part of acetal formation. Like I said in the first part, I told you guys that I will be going over the reaction mechanism, and I will keep my promise, and I'll be going over the reaction mechanism in this part, the forward and the reverse. So let's get started. And so this is a 7-step reaction mechanism. It's not like your typical first semester organic chemistry class where you deal with 2, 3, at most maybe 4 steps. This is where it really starts to kick in, the second semester organic chemistry reaction mechanism, where you'll start to see 7, 8, 9, 10, maybe even 11, 12 step reaction mechanisms. So this is a pretty good practice of going over reaction mechanism of really long reactions. So let's get started. First thing you want to do in this reaction, again, you have a ketone or an aldehyde as your starting material. You want to protonate the oxygen by using the lone pairs on the oxygen. So you're going to form a bond between the oxygen and the hydrogen using the lone pairs. So now you have your protonated system. The oxygen now has 3 bonds attached to it, so therefore it carries a formal charge of +1. So what we do now in this second step is we send the first equivalent of our alcohol, and it makes a bond between the oxygen and the carbon of the carbonyl using its lone pairs. Okay? So now you kick off a pair of electrons here from the double bond onto the oxygen. So that's your second step. You have formed this intermediate here. You have an alcohol, plus you have a formal charge of +1 on the oxygen. The next step, which is the third step, you want to kick off basically a pair of electrons that is found between the oxygen and the hydrogen onto the oxygen. So this oxygen now is no longer bonded to this hydrogen. You lose the hydrogen completely. And now what you form is your first ether. Again, the ether uses the carbon of the carbonyl as one of the carbons required for the ether. Next step, you want to protonate your alcohol over here. The reason why? Because you want to kick off the alcohol to add your second alcohol into the system. Okay? Sounds a little bit confusing, but just bear with me. You protonate this alcohol using its lone pairs to form a bond between the oxygen and the hydrogen. Now you've formed a pretty good leaving group. You kick off this soon-to-be water, okay? And now you have formed a carbocation, okay? Now in the next step, your second alcohol adds into the system. Using this lone pairs on the oxygen, it forms a bond between the oxygen and the carbon that bears the positive charge. Now what you have formed is this intermediate. You have one ether here, and you have almost your second ether, but you need to lose the H. So that's what we do. We kick off a pair of electrons onto the oxygen, losing the H, and that is exactly the same step we did over here to form our first ether. Now we're doing the same step again here to form our second ether, and there you have it. There's our acetal, and we formed H plus as a byproduct. We didn't really form H plus as a byproduct. If you have noticed, H plus was a catalyst. Okay, it was used in the beginning of the reaction, and it reappeared at the end of the reaction. So H plus was our catalyst. Okay, so that is the forward reaction. And for the second reaction mechanism, I'll be focusing on the reverse. And here's the reverse. we're starting off with an acetal, and now we want to form our ketone. Okay, so again, the reagents we use is H plus H2O. So let's get started with the reaction mechanism. First thing you want to do is protonate your oxygen. Okay, you want to protonate this oxygen, so you're going to use the lone pairs. So you could, okay, so before I move on with the step, you could choose this ether or this ether. Okay, you could protonate any one of these oxygens. It doesn't really matter. I protonated this one because it's the closest to H plus. Okay, so it's, I don't have to draw a really large arrow. So I protonate this oxygen using the lone pairs on it, and that was the first step. Now what we do, we form this intermediate. Okay, so we kick off this leaving group. Okay, we kick off this leaving group, and this leaving group is our first equivalent of the alcohol. And as you guys can see, the byproduct of this step, of the second step, I've drawn up here and I boxed it in, and that's our first alcohol we have formed as a result of this step. Okay, the protonated oxygen is a good leaving group, so we kick it off like we have done here. So we break the bond here, and we kick off 2 electrons onto the oxygen. And now what we do is use one of the lone pairs on the oxygen here, the oxygen of the ether, to form a double bond between the oxygen and the carbon. Okay, now what we have formed over here is this intermediate. Okay, we have a C double bond O, but this oxygen has a positive charge because it has 3 bonds. The next step, which is the third step, is that we introduce water into the picture. Water, okay, we use the lone pairs on the oxygen to form a bond between the oxygen and the carbon here. Okay, all the reaction, all the chemistry is occurring mostly on this carbon present here. So the oxygen forms a bond here with this carbon, kicking off one of the bonds here onto the oxygen. Okay, so one of the bonds of the double bond is kicked off to the oxygen, and now you have formed this intermediate here. You have one of your ethers, and you have this intermediate over here, this oxygen with three bonds. Now you do a proton transfer, and as far as proton transfers go, all a proton transfer is transferring a hydrogen to this oxygen over here. Okay, that's what proton transfer is, transfer of a proton, which is an H. You're transferring this H onto this oxygen, and that's exactly what we have done here. This is showing the result of this step, and for this specific proton transfer you don't have to show any arrows or anything like that, electron pushing arrows or anything like that. All you have to just state is proton transfer. So we move this hydrogen onto this oxygen here, and now we have an alcohol and this other good leaving group, which is our second equivalent of our alcohol. So we kick off our soon-to-be alcohol. We kick off this pair of electrons here onto the oxygen. We have our alcohol, and now we have, I forgot to put a positive charge here, and we have this carbocation. Now what we want to do now is kick off the pair of electrons found between the oxygen and the hydrogen to form our carbonyl, and that is exactly what we have done. So as you guys have noticed, we have formed, as a result of this reaction, 2 alcohols and our ketone, and that's all it is in regards to the reverse reaction mechanism, starting off with an acetal and going to a aldehyde or ketone. And in this specific case, we went to a ketone. So Thank you guys for listening. I hope you guys enjoyed. I hope you guys learned something. This is Moballer12, and I'm signing out.